Hi, I'm Peter Haddock and I'm here with Sencieve. Now, Sencieve is a company I've never ever been talking to before. We're here at Geo Business and I'm with Simon. Simon, you're a product expert for Sencieve here. And these are the things that matter, Simon. These are sensors, highly accurate sensors in all shapes and sizes that you use to actually monitor critical things that are happening in the construction world. That's really exciting to me. You've talked to me earlier about all those different applications, but first of all, I want to know what's inside this and why is that important for the industry?
Well, inside those little cases there, you've got a MEMS-based sensor which measures rotational movement. These are triaxial sensors, and they will pick up movement with a great deal of precision, down to 0.001 degrees. So wherever you're concerned about movement, whether it's sudden movement like a landslide or a bridge strike, or whether it's much more gradual movement like convergence or settlement in a tunnel, these things will, once they're installed, they will pick it up. They will pick up that movement in the short term, and they will pick up longer term patterns of movement without you having to be there.
Right, so these things, because they're so small, folks, you can actually put them in hard to reach human places for measurement, which also means you can actually build in spots for these to actually be mounted. With this back on here, it's actually a magnetic mount, so you can mount it quite simply, but also, with it being quite small, you can put it in all sorts of different places.
The really clever thing here is actually the wireless communications platform that links those things, that brings them together. You see, we put a whole series of those out across the site, and they will talk to each other. They'll transmit data to their neighbor, and then onwards through that mesh. They will build a mesh network, the radio network themselves, communicate that back to a gateway that will generally use the mobile phone network and send that back to a stakeholder.
So what's interesting is, on a big site, say HS2 on a big site, the biggest in the UK at the moment, we can have these sorts of sensors close to each other at different points in a tunnel, for example. And then what happens, folks, is that one talks to this one. This one then relays more information. And then it goes all the way through to the most important sort of communicator, and that is your actual end piece, isn't it? Tell me a little bit about that and the fact it's also, folks, cleverly solar panel.
Yeah, the gateway's a clever piece of kit because it's there primarily to harvest the data from the sensors and then to relay it back to the stakeholders. So it does that, as long as it's got power and a mobile phone signal, then it will do that with a very short lag time from receiving these pockets of information from the sensors. But if there is a problem, it can also store data on board, typically up to 30 days of storage on there as well. So you've got the ability, the redundancy in that system to harvest data live or to store it if there is some sort of breakdown in the mobile phone network. You've got a weak mobile signal, for example. So it's quite a robust system in many ways, really. I think a point that really is also relevant there is about that whole robustness. The software platform that sits above this has taken about 15 years of development. This really started, around about 2005. The core of the really clever part of this whole package isn't really smart sensors, isn't really the gateway. The smart bit is this software that allows these things to talk to each other, to form this mesh network that's smart enough to self-heal. If one of these devices goes down, the shortest, easiest path back to the gateway is lost. It says, "I've lost my friend. What am I going to do? I'll find another one. I'll go back that way." Really, we install these on the site. We put them out there. There we go. And we can pretty much leave them. There's a bit of configuration to do in the office, but they will find their own network. They will form their own smart network. They are transmitting as soon as you put them out there. And that platform is incredibly robust. It will work in all sorts of conditions, weak radio communication conditions, all sorts of weather. We've got these working up near in Arctic conditions. We've got them working in really, really hot desert conditions. It's a very, very robust system, both in terms of its sort of electromagnetic performance and its physical characteristics.
So there's a lot packed into this small sensor, folks. And what's really interesting for me is that you can also look at the data that's coming off this and trend that data. So you can have an immediate alert. Say there's been a landslide on a Network Rail project, and basically we need to stop the trains. This can send an alert to there, and instantly we are getting that going through to the gateway, and people can stop trains and they can prevent an accident. Crucial big factors. If we're holding up with some formwork, a really big structure, and all of a sudden some of the really sensitive shear bolts that are holding the critical support structures up, they fail. We get people out of the way and on site. However, if we're just taking readings and little bits of data here and there, what happens is that data builds up, doesn't it? And your software system allows you to look at that trending data as to what happens, because actually, if you have a trend, folks, which we can see a weakness in something, it's in a network or it's on a structure, then actually we can look at when we should do preventative maintenance, or when we should actually look at sending that out as a big red alert to other things that are using that kind of system. So other places that are having the same kind of shoring, or other places that have got the same concrete mix, for example. Yeah. All of this is really exciting because it allows a project to talk to us now and in the future. And these ping very, very small amounts of data. So the battery life of this is quite good, isn't it?
The battery life is pretty remarkable, actually. I think that the software engineers, the electronics engineers behind these designs have really put the pressure, they've squeezed the power consumption down to an absolute minimum. It requires very, very little juice to keep powering that system, to the extent that, you know, if you install that now and you have it reporting for every 30 minutes on a 30-minute period, that's still going to be working in probably 15 years' time.
Wow. So that's it, folks. First time I've come to see the team at Sencieve. Little sensors, all different shapes and sizes, all different applications, fundamentally clever stuff in here that basically goes to the gateway, that then talks to clever software that can save us loads and loads of money on projects, but also can keep us all safe. And we can actually measure stuff anywhere as long as we can send it back to a gateway that's got a mobile signal. So fantastic to meet you here today. As we've seen behind us, lots of different applications for this. Trucks, trains, rail projects, all sorts of things. And it's fantastic to see us moving forward with sensor technology that can do so much in the industry.